So good morning, everyone. Thank you for having me here in Cardiff. It's great to be here to talk to you about serverless and CI/CD. As Matt said, my name's Microsoft. My name's Dean, and I work for Microsoft. This is my colleague Clippy, that some of you may be familiar with from yesteryear. As a developer advocate, our job is really just to engage with the technical community as engineers, talking to you as engineers, just to really understand how we can make your lives easier with both Microsoft and open source technologies. So if there's anything interesting that you want to talk about in the break, I'd love to have a conversation with any of you about that. Prior to Microsoft, I spent a few years working at AWS as a solutions architect, and then I worked on the Alexa team, helping launch Alexa here in Europe for the UK and Germany when we first launched. So similar to kind of what Jan said, there was this kind of big movement in 2014 when serverless came out, and I was fortunate enough when I worked at AWS in 2014 to be on the internal beta for Lambda before it launched. So I've been doing serverless for a little while, and obviously in my Alexa career as well, there's a lot of stuff that happens in the serverless space there. It's kind of a really nice fit for serverless when building bots. So I've been doing this for a little while, and I just want to share some experiences around continuous integration, continuous deployment, Devops really, with serverless. So you've probably all seen all of these reports where you've got serverless and all the massive benefits we're going to get. We're going to get cost savings, agility, we're going to get all these things, and Jan mentioned some of those. And then you've probably seen similar reports for DevOps that say almost exactly the same thing. We're going to get faster feature velocity, we're going to get reduced mean time to recovery, we're going to even increase our revenue, our overall costs are going to come down. So I was thinking that if we can kind of do serverless and DevOps, then we're kind of in heaven, right? We're in this kind of optimal situation. Well, I think part of that is because a lot of the benefits we get from serverless is because there's a reduced element of DevOps that we have to really worry about. It takes care of a lot of that heavy lifting that we never really had to do before. But there are some kind of unique things to serverless as well, which we're going to talk about during this session. So I'm going to make some assumptions before I kind of start this talk, is that you know what these three things are. And just in case anybody doesn't know what they are, I'm going to give you a 30-second whirlwind tour of Dean's definition of what these three things are. So firstly, we're talking about continuous integration. And this is our source control for our code, getting that source control to be built, unit tested, and packaged and ready for deployment. And then we'll talk about CD, or continuous deployment, and this is taking that package and putting it through a number of stages, doing our functional testing, and releasing that code out into the environment. And we'll talk about automation a lot in that space and how we can automate this whole process. And third thing is infrastructure as code. And this is defining our infrastructure in a template, maybe a JSON or a YAML template, and treating it like it's code. So we're version controlling it, we're submitting it into Git, and doing things like that. So who here is doing all three of these things today with serverless? Cool, so we've got a few people doing that. Who's doing infrastructure as code? There's a few. Cool, so there's a few people doing that as well. So they're the kind of three things I'm going to focus on at the moment. And some of you might be thinking, and some people put their hand up and they said, I'm already doing all of this, Dean, right? I'm already doing all of those things. I'm doing CI, CD, and I've got infrastructure as code, and the world is great. And maybe you're even doing that in a non-serverless environment as well. Maybe you're using containers, maybe microservices, maybe you've got a monolithic app where you're doing that as well. So I spent some time thinking about how things might be specific to serverless when we're looking at CI, CD, and DevOps. And there were three kind of key characteristics of serverless applications that sprung to mind. So the first thing is that serverless, as Jan really nicely pointed out as a primer to this talk, is more than just functions as a service or FAS, right? It's a bit of a bugbear of mine when people say, oh, our serverless offering is Azure Functions or something like that, right? That really kind of gets at me a little bit. So the point there is that you haven't really got a decent application with just a function, right? You're going to have some accompanying services. And they might not meet those three criteria of being instantly scalable, complete abstraction of servers, and never pay for idle. They may have one or two of those characteristics, but not all three. But in order to make a serverless application, you need pure serverless services like functions, and you also need accompanying services as well. So our serverless applications are more than just our logic or our application code. So that's kind of important and a little bit unique in some ways, which we'll get to. The other thing is our unit of deployment. Our unit of deployment is smaller. It's our function or our function app. So our unit of deployment is significantly smaller than if we were doing a monolithic app, for example, where we're deploying our entire application. So we need to look at how we can leverage CI tools to help us do independent builds and things like that. And lastly, the other thing is that these things have a short life cycle, right? Our functions only really exist when they're invoked. And they don't cost us anything when they're not being used. We don't pay for idle. So this makes them really, really cheap to run, and there's some benefits for that as well. And then I just want to, before we kind of dive into how we actually do this, what kind of experience are we looking for with serverless CI/CD? What do we want to achieve from it? So these are the characteristics of serverless, and here is what we kind of want to achieve. So first of all, we're probably already using pipelines or some kind of CI/CD tool, whether that be Jenkins or Azure Devops or CodeStar or whatever it is you're using for that. So we want to leverage our existing knowledge, so we're probably still going to use some kind of pipeline for building and releasing our code. We also want to automate wherever possible. We want this to be triggered from a commit to our Git repository. And then later on in our release cycle, we have this nirvana of this complete automated deployment pipeline all the way through to production, right? So we'll talk about how we can kind of get to that nirvana stage. We also want to build these once. We want a single artifact per deployment that we can push into our release pipeline. We just want to do that once for every single deployment or every single commit. That's important to us. And we want, as we already have today, probably, hopefully, independent environments, right? So we're going to deploy or release through a different set of stages. We're going to have maybe a development, a testing, a staging, a QA, and then maybe a production environment. We want those to be independent. And then we want some level of repeatability throughout those environments so we can ensure that when our code gets to production, it's in the right place. So that's really important to us as well. So they're the kind of experience that we're looking for. How do we kind of leverage CI/CD and serverless, and what are the kind of specialities or the specific things to serverless around that? Well, the good news is that to achieve all of this, you don't actually have to change a ton of stuff. A lot of the things that you do today, if you're already doing CI/CD and infrastructure as code, they're pretty similar. You should continue to do them in the same way. But we'll look back at those kind of three characteristics of serverless and some kind of tweaks and changes you might make in your process, given the characteristics of serverless applications. I spent a lot of time researching. I was trying to find these really individual things. Like, it must be completely different when we're doing CI/CD with serverless. But the reality is that if you're building modern applications, and particularly microservice-based applications, a lot of this knowledge is transferable to those services as well. So I've spent far too much time standing in front of slides. So I want to show you CI/CD pipeline and some infrastructure code for a serverless application that I've got to kind of show you some of the nuances and some of the things that I've kind of configured around that. So, make sure this works. Where is my mouse? There you are. Cool. I might have to make this a little bit bigger. So I'm using Visual Studio Code here. Who uses Visual Studio Code? Rocks, doesn't it? Love it. And not just because I work for Microsoft. No, lots of people that don't like Microsoft that use Visual Studio Code. It's awesome. The extensions are one of the key benefits for me. So one of the things that I love about Visual Studio Code is the extensibility. If you're using Azure, the Azure extension here you can see on the side. Make that a little bit bigger. We have extensions for a bunch of Azure services that make it really easy to kind of build our function apps, run our code locally, test them, and do all that kind of local development stuff. A complete side note, but one really nice thing about Azure Functions is that the runtime is completely open source. So when I run my Azure Functions locally on my machine here, I'm running the exact same runtime based on .NET Core on my Mac as what I would be running up in the Azure cloud as well, which makes a really nice portable environment for testing my stuff locally. So I have this repository here, and it's a kind of, I wouldn't like to call it a mono repo, but it is a repository that consists of multiple services. So I have a user service and an event service that you can see here. Also have some ARM templates. ARM, or Azure Resource Manager, is our infrastructure as code for provisioning our infrastructure as a JSON template. This is similar to Terraform or CloudFormation that you might be familiar with. So just to look at this, basically I have this template here called Azure Deploy. What this does is it just creates a storage account. You can see there. It creates sorry, bear with me, it creates an Azure storage account, which is where we're going to store some stuff for our function. We're going to create an app service plan, which is called a web server farm. Azure Functions runs on top of Azure App Service. We're then going to create our actual function app itself. We're going to give that some properties and some application settings, like what our application insights instrumentation key is for our monitoring and stuff like that. And then we're going to do some, then we're going to create our application insights for our monitoring. So this is basically just going to go and deploy all of our resources that we need to then deploy our function to. Note that what I've done here, and this is one of those characteristics of serverless, is that I've coupled my infrastructure template very closely with my application code. So this is something that you probably might do in other situations as well. I've seen it done both ways, where maybe there's a infrastructure as code pipeline for your infrastructure, maybe to create your AKS cluster or something like that. It's got its own pipeline for Kubernetes maybe, and then you've actually got your code pipeline where you're deploying your images or to that kind of cluster or something like that. In serverless, it makes sense to couple these together because that's our kind of unit of deployment. That's everything that we need to deploy that function or that small microservice. We could have more stuff in here. We could have a Cosmos DB, NoSQL data store. We could have some other stuff, a CDN or an API gateway or something like that. But coupling those together is really important. And because it's cheap, we're not really paying for anything. It doesn't cost us anything if we're not running it. It makes sense to couple those together and have repeatable environments. And we have our production environment looks exactly the same as our QA and our testing environment, and we've got that repeatability and consistency throughout. Now, I know that isn't always possible traditionally. When I've worked with customers in the past, in previous life, when people were using big servers in production and they had to have smaller servers maybe in their test environment or different kind of spec, or maybe they haven't got the same scaling properties or something like that because it's just expensive. In serverless, we don't have to worry about that. We can couple our infrastructure as code with our application code and we're laughing. So we've got our function code, our infrastructure as code there. This is for deploying my event service, I believe. They're both exactly the same. They both deploy exactly that stuff. And then in my actual functions here, you can see that I have, this is the structure for Azure Function App. It's relatively irrelevant to this talk, but every function, you can have multiple functions within a function app, but the function app is your unit of deployment. So you can have one or more functions within that, and that's an architectural decision that I guess is down to people who are using this to make. So we have a function here called getEvents. We have a function.json, which is the metadata or configuration for that specific function, telling us that our trigger is a HTTP trigger. We don't need to put an API gateway or anything like that in front of it. We have a native HTTP trigger into our function, and we're going to have an output of HTTP as well. So it's a request response model. And then in my index.js, it's the simplest function you've ever seen in your life. It just says, welcome to events. And no prizes for guessing what the users one says, because that just says, welcome to users. So that's completely irrelevant to the point of this talk. So if we kind of edit something in here, so we can say, welcome to events Cardiff, and we'll save that. And we can do welcome to users Cardiff, and we'll save something like that. In Visual Studio Code, we've got this really nice Git integration, so I can just add those files, put a commit message, Cardiff will do, hit tick, and then we can push. So we're going to push those changes. Oh, Git fatal. Oh, we love that. Just do it here. Maybe I need to think about it. Oh, we'll come back to that. We don't have time to work that out. So I'm using a product from Azure called Azure Devops for my CI/CD pipeline. Now, Azure Devops is, it was previously kind of called VSTS or TFS. People might be familiar with it from those terms. It's a really, really cool service, and I'm not just saying that as a Microsoft employee. So you can deploy any language to any cloud, to any environment, to your on-premises environments, to your AWS, to your Google environment. My demo is going to show Azure, but you can use this as an independent product, whether you're using Azure or not, for your serverless environments. And it's a really nice, robust tool for a bunch of DevOps stuff. So we've got Kanban boards for tracking our progress and our issues. We can actually host our Git repositories there as well. We can have our pipelines, our build and our release pipelines, our test plans and our artifacts. One really interesting thing about Azure DevOps, or two really interesting things, one is that it offers a hosted macOS version if you are completely managed, if you're building iOS apps, which is pretty neat. And secondly, if you're building open source projects, you get unlimited build minutes for 10 concurrent builds for free. So you don't have to pay anything to use the service, and you can have 10. For private projects, you don't have the concurrency. You get one concurrent build for your private projects. So I've just created a really simple project called Serverless Days. My repository is actually, oh, that might be why we can't connect. The Wi-Fi's gone. Haha. No wonder my git push didn't work. Where are we? It's back on, I think. I was like, that repository does exist. So very quickly, kind of whizzing through this here, we've got, so my code actually sits here. This could be in GitHub, it could be anywhere that it needs to be. So we integrate with GitHub, Bitbucket, and other services as you might wish. You can see my code is here. And then all I do is I have a build pipeline. It's called mono CI here, that is triggered based on a commit to that repository. So you can see here that my source here, I can choose GitHub, Subversion, GitHub Enterprise, Bitbucket, etc., or any kind of Git repository. What I'm doing here is I have two builds. I have a build for users and a build for events. So I'm building both of those services within my kind of mono repo independently. So they both have individual builds, and they both deploy their own artifacts and publish their own artifact for my release pipeline to pick up. Now, one way that you might want to do this in my scenario here, everything's going to happen at the same time. So in parallel, we're going to go and create our users, and we're going to go and create our events. But I might have only updated my users. So one thing that we can do there is we can actually have these pipelines, triggers for the pipeline from our repository. We can add what's called a path filter, which you can see here. And we can put in here and we say, actually, we only want to include users /start. So what that will mean is that it will only trigger that pipeline if I update code in my users directory within that Git repository. Now, if you're using other CI tools, some of them support this. Other things I've seen is people use bash scripts or PowerShell scripts to look at the Git commit and see what's actually changed and whether it's in the right folder. This is a really neat, elegant way for us to be able to do that. You would need to have independent build pipelines within the project for that, which is more than feasible. We won't save that. But you can see that all my build pipeline does here is it runs a bash script. That bash script CDs into users and then does an npm install. I then package up that users directory as a zip file. I copy my Azure Resource Manager templates into that folder, and then I publish an artifact. It's really as simple as that to get this set up, and I can do that twice for the different events, either independent build pipelines based on a different repo. If you're doing multi-repo, maybe you've got a repository per microservice, or using the path filters if we're using the mono repo setup. And then once that build is complete, or once that build is actually happening, I'll leave that. You see I've got this one called Cardiff that I may have completed. So you can see in detail actually what happens. You can see my bash script there. You can see all of my npm warnings for the fact that I haven't got a readme and everything else that I haven't done for this demo. And you can see exactly what's happened there, and you can even see the artifacts that it's published here. So we can see there that we've got a zip file, and we've also got our deployment for our infrastructure as code. So we're doing all of this coupled together in a nice kind of coupled way. That will then trigger my release pipeline, which should be running now. It says, what's going on? Here's one I did earlier. So this artifact being published triggers this pipeline. We have a staging pipeline, and then ultimately a production pipeline. If we go back to our release, we can click on edit. You can see that all that does is, in these tasks, it again has two jobs. It deploys Azure Resource Manager template for my users, creating all of the infrastructure, and then it deploys my code to that. And that's an incremental update. So if the code already exists, or the infrastructure already exists, I'm deploying for another time, and I haven't updated the ARM template, then nothing will happen to that. It will just take a couple of seconds to just validate there's no changes required. And then we will go and then deploy our code to it. If there's something I've updated in my infrastructure as code, in my ARM template, it will go and do that as well. So we're kind of covering both angles, updating our infrastructure, our resources, as well as updating our application code, all within a single release. One thing to just quickly note is that if we look at our pipeline, we have these post-deployment and pre-deployment gates. So here you can see that I've allocated myself as an approver at the end of the deployment here, so it won't go into production until I've actually approved that it can go into production. But we also have this cool feature called deployment gates. And we can add gates here, so we can actually do things like check a monitor alert and see if there is some kind of metric that's been met or not met and decide whether to deploy to production or not. We can also invoke an Azure function. My friend worked with a hospital where they had to have somebody sign a physical document before something could get pushed into production. So they convinced them to use DocuSign, and then they used an Azure function to query the DocuSign API every 5 minutes. And then ultimately, they could automate that process. So this is how we get into that kind of ultimate automated CI/CD at the end. So I know that I'm out of time, so I just want to very quickly summarize before I get rugby tackled off the stage. So to summarize is that you don't have to change everything, right? You should think about the unique properties of serverless and how you might adapt things, like coupling your infrastructure, making those completely repeatable. Most of these principles can be applied in any microservices architecture. It's just a no-brainer when we're doing serverless, right? You don't have to do them with other microservices or other architectures. You can do them, but when you're doing serverless apps, it's a no-brainer to do and apply these practices because it just makes your life a lot easier, it's cheap, and it's easy. So with that, I'd like to thank you all for listening. Feel free to follow me on Twitter for any all fun serverless DevOps-y stuff, and yeah, thank you.